Madison Square Garden sits directly on top of Pennsylvania Station. Most people already know that part. What most people don't know is what it actually took to put it there. 5 years, 600,000 passengers moving through that station every single week, and not one day when a scheduled train failed to run, while the station around those passengers was being torn apart floor by floor and rebuilt into one of the most famous arenas on Earth, directly on top of the wound. Picture the beast that came out of that 5-year fight. A drum of concrete and steel 150 feet tall, 404 feet across at the roof, squatting over 7th Avenue like it had swallowed the block whole. Nothing holding that roof up from the inside. Just cable, weight, and nerve. Below it, 21 tracks and 11 platforms that never stopped moving, not for 1 hour, while the garden climbed on top of them. Nobody warns you about this part going in. At platform level, crews were driving 500 new steel columns into the ground, one at a time, inches from a live third rail, carrying enough current to kill a man on contact, while commuters walked past on the other side of a sheet of plywood, close enough to hear the torches. One misjudged swing of a crane boom, one column set a few inches out of true. That is genuinely all it would have taken to turn the busiest transit hub in the country into a catastrophe nobody could undo. The men running those machines knew that, every day, for 5 straight years. So how do you tear a building down without ever closing it? How do you sink steel into the ground beside a live rail and not lose a single scheduled train? How do you raise an arena roof over the busiest railroad on the continent and get every lift right the first time, because there is no second time, not with a train underneath? What follows is the story of the machines that pulled it off. The cranes, the derricks, the steel gangs working inches at a time above a railroad that refused to stop moving for anybody. And it's the story of what actually happened to the old Pennsylvania station everyone assumes got hauled away and forgotten. It didn't. Stay with this one. It's still down there. The numbers nobody believed. Start with the number that should be impossible on its face. Across 5 years of demolition and reconstruction, not a single day of train service into Pennsylvania Station was lost. Not one. The busiest rail terminal in the Western Hemisphere ran on schedule, while the building on top of it was torn apart and rebuilt from scratch. Under the finished arena floor right now sits roughly 15,000 tons of steel, poured and driven into a foundation that goes 50 feet down from street level. A slab of engineering covering an area close to the size of 8 football fields laid side by side. Almost none of it will ever be seen by a living soul. It was built to be buried on purpose, carrying a load most people walking overhead will never think about for a second. Above that, another 14,000 tons of steel went up to form the superstructure itself, the skeleton of the arena, raised in open air by a small fleet of cranes and derricks, over tracks that were still moving trains underneath it the entire time it climbed. This next one sounds made up, but it isn't. Roughly 500 new support columns were sunk down into the working guts of an operating train station, through platform level, around live third rail, inches from moving equipment, while passengers walked past on their way to catch a 610 to Long Island. The only thing separating a commuter from an active demolition and construction zone, in some stretches, was a sheet of plywood. Then there's the roof. 48 cables, each one about 1 3/4 inches thick. You could close your fist around one, composed of over 250 individually wound steel wires. Each cable was rated to hold roughly 800 tons before failure. Multiply that out, and you get a roof system holding tension numbers that, at the time, had never been attempted on a building this size in this city. A drum of concrete and glass, essentially hanging from wire. One more, before we go back and build this thing properly from the ground up. Underneath the arena floor, below the seats, below the ice, below everything 20,000 fans will ever see on a game night, sits an entire second building nobody talks about. A 5,000-seat theater, a cinema, exhibition halls, a bowling alley, a hidden structure buried in the same footprint as a demolished train station, built at the same time, by the same exhausted crews, with the same trains running beneath all of it. And the fact this whole story is actually walking toward the one we're not explaining yet. When the wrecking crews finished and the steel crews closed the roof, the old Pennsylvania station wasn't hauled away into memory the way people assume. It was buried, Whole sections of it, the same 21 tracks, the same 11 platforms, laid out on the same footprint, are still down there right now, still running trains, sealed under 150 feet of arena. Hold on to that one. It's the reason this entire operation had to happen the way it did. The railroad that sold its own front door. By the late 1950s, the Pennsylvania Railroad was sitting on the most valuable real estate in the Western Hemisphere, and going broke anyway. Passenger rail had been bleeding money since the war ended. Foot traffic through the station had peaked at over 100 million passengers a year during the 1940s, when troop trains and wartime travel packed every platform. By 1960, that traffic had collapsed to a fraction of intercity travel in America, as cars and airplanes ate the railroad's business alive year after year. The company that once ran more track than any private enterprise on Earth was staring at a terminal building so large and so expensive to maintain that keeping its doors open had become an act of nostalgia the balance sheet couldn't justify anymore. The building itself was staggering by any measure. 2 full city blocks, 9 acres of Beaux-Arts limestone and pink granite, modeled loosely on the Roman baths of Caracalla, with a glass-roofed concourse so vast that outside light used to spill straight down onto the platforms below. It had cost the railroad well over $100 million to build in 1910, a fortune at the time, poured into columns, arches, and a waiting room some called the largest indoor space in the entire city. That was the before. The after had to fit into a fraction of the footprint, hidden below street level, air-conditioned instead of daylit, functional instead of monumental. The railroad wasn't just trading a building, it was trading grandeur for survival. So the railroad did what a company running out of road does. It looked up, above the tracks, above the platforms, above the marble concourse that had welcomed presidents and immigrants alike since 1910. There was empty air. Air the railroad still owned. Air that, in Manhattan, was worth more than almost anything else in the world. In 1960, a real estate operator named Irving Mitchell Felt bought the rights to build on that air. Felt ran a company called Graham Page, which, strangely enough, had started life building automobiles before pivoting hard into real estate and buying a controlling stake in the aging third Madison Square Garden a few years earlier. 2 years after securing the air rights, in 1962, his company announced what it planned to put on top of the railroad. A new home for Madison Square Garden, an arena that had bounced around the city under that name since 1879, this time landing on top of the busiest train station on the continent. In exchange for the air rights, the railroad would get a brand new station built underneath, at no cost to them, plus a quarter share in the new arena complex. On paper, everybody won. The public did not see it that way. When the plans went public, modern architects, the very people whose entire aesthetic rejected the ornate, old-world style of the original station, rushed to defend it anyway, calling it a treasure worth saving regardless of taste. They rallied outside the building, chanting a line that stuck: "Don't amputate, renovate." City planners voted to proceed with demolition in January of 1963 regardless. Felt's own defense of the decision became almost as famous as the protest against it. He said that 50 years from then, when it came time to tear his new arena down in turn, there would be a fresh generation of architects protesting that loss too. The problem was the address. The old Pennsylvania station wasn't some outdated depot that could be shut down and quietly cleared. It was still processing over 600,000 passengers a week. Commuters, tourists, servicemen coming home, families heading nowhere in particular. You cannot simply pull the plug on that. The city doesn't stop needing to get to Long Island because a wrecking ball showed up. Demolition of the head house began on October 28, 1963, under the authority of the railroad's president, a man named Stuart Saunders. Architects picketed outside. 6 of them called it a public disgrace to the New York Times the same week. A model of the finished replacement had already been drawn up by the architect Charles Luckman. A circular arena, unlike almost anything the city had seen, partly inspired by a stadium an architect had built years earlier in Uruguay. The design existed on paper. Getting from the paper to the steel meant tearing the roof off a working terminal without ever closing it. The mystery isn't whether they could tear the building down. Anyone with a wrecking ball can tear a building down. The mystery is how you do it with 600,000 people a week still walking through the wreckage on their way to work, and what it took to keep every one of those trains running exactly on time while it happened. That answer starts with a piece of engineering most passengers walked over without ever noticing. Building a cage around a live wire. The first move made everything else possible. Before a single stone of the old head house came down, crews built a giant steel deck over the tracks and platforms, a temporary roof of raw structural steel, laid across the working guts of the station like a lid clamped over a pot that was still boiling. Above that deck, demolition could proceed. Below it, trains kept running exactly as they always had, because most of the actual railroad infrastructure, the concourses, the waiting areas, the platforms themselves, sat below street level to begin with. The old station's grandeur was up top. Its working machinery was already buried. That deck let one crew operate above the other without either one ever touching. The reason not a single day of service was ever lost traces straight back to that deck. It physically separated the demolition crew from the working railroad for most of the job, a sheet of engineered steel thick enough to catch falling debris and strong enough to carry the weight of the machines working on top of it. But a steel lid over the tracks only solved the demolition half of the problem. It did nothing for what came next. Building a new arena's foundation straight down through a station that was still moving trains beneath it. That's where the 500 columns came in. Somewhere between 1964 and 1966, crews began sinking new support columns down into the platform level of the working station, using pile-driving rigs squeezed into gaps barely wider than the rigs themselves. Some existing columns from the original 1910 structure were reinforced to carry additional load. New ones had to be threaded down between live rails, positioned with a precision that left almost no margin, close enough to the electrified third rail that a careless swing of the rig could have been catastrophic, close enough to a moving train that timing wasn't a preference, it was survival. Every blow of the hammer had to land exactly where the survey stakes said it would, because there was no room on either side to correct a column that had drifted even a few inches off true. Passengers were routed around these work zones by nothing more than plywood partitions, walking past active pile driving on their way to catch a 640 to Trenton. Under the tracks, another kind of work was happening that almost nobody walking overhead would ever see. Crews laid what engineers call grillage, a dense lattice of heavy steel beams, crossed and bolted into a network strong enough to spread an enormous load evenly across soft ground 50 feet down. Concrete crews followed behind them, pumping and pouring around the grillage in sections small enough to fit the gaps between live track, working the wet concrete with vibrating pokers to force out air pockets before it set, because a foundation full of voids 50 feet under an arena was not a mistake anyone could go back and fix later. On top of that grillage and those pours sat the beginning of a foundation that would eventually swallow roughly 15,000 tons of steel, covering close to 8 football fields of underground footprint. Buried tonnage nobody sees, and the reason the ground beneath the arena can carry 20,000 fans without settling an inch. That foundation had to do more than hold up an arena. 2 full levels were carved out beneath the seating bowl for a 5,000-seat amphitheater, a 500-seat cinema, exhibition galleries, and a bowling alley, an entire second building's worth of program, stacked underground, squeezed between the new station concourses and the arena floor 45 feet above. Every one of those levels had to be dug, formed, and poured inside the same cramped, live railroad envelope as everything else. There was no direction to expand except down, and down was already occupied by a working railroad that had first claim on the ground. Worth sitting with before we climb back up into daylight. Pound for pound, a steel cable under tension is 3 to 4 times stronger than a solid bar of the same structural steel, which is exactly why an entire 20,000-seat roof could hang from 48 thin cables instead of resting on a forest of interior columns. It sounds almost like a magic trick. It isn't. It's the same principle holding up a suspension bridge, just turned sideways and closed into a circle. There was no room for columns down below, because the railroad was already there, so the roof learned to hold itself up without needing any. By late 1965, the first real girders for the new structure were finally rising into daylight. A New York Times headline that October put it plainly. The garden was starting to rise at Penn Station. The project stopped being demolition and became construction the day 14,000 tons of superstructure steel started climbing. Raising that steel took machines built for exactly this kind of brute force precision. A 60-ton crawler crane and a 70-ton derrick lifted the massive perimeter columns into position, one after another, ringing the site like sentries. Both machines had to work within a swing radius that, in places, put their loads over live track, meaning every lift was planned around where the boom's shadow would fall, not just where the steel needed to land. A crawler crane can tip if its load swings past the edge of its rated radius. A derrick, guyed and anchored to the ground it stands on, can wrench its own foundation loose if a load snags or shock loads unexpectedly. Neither machine got a margin for either mistake, not on this site. To move workers and materials up through the rising frame, crews relied on temporary material hoists bolted to the steel as it climbed, open cages and platforms riding guide rails, hauling tools, bolts, and bagged supplies to men working 70, 90, better than 100 feet above the tracks. A hoist on a normal job is routine equipment. A hoist on this one meant every load swinging up past open floors, past gaps where a dropped wrench or a loose plank had a clear, unobstructed fall straight down onto a platform full of commuters. The arena floor itself, sitting 45 feet above street level, was carried on heavy welded plate girders, their joints spliced with steel cover plates 3 feet wide, cinched together with high-strength friction grip bolts instead of rivets. Crews drove those bolts home with pneumatic torque wrenches tuned to an exact tension, a fastening method chosen because it could be tightened to precision without the sparks and open flame of old-style riveting, a genuine advantage on a site already packed with dust, fuel, and moving crowds. From that 45-foot floor, the real climb began. A truck-mounted crane carrying a boom 170 feet long, with an additional 30-foot jib bolted to the end of it, like a fishing rod lashed to a cannon, reached up and set the roof steel piece by piece. A boom that long sags under its own weight and sways in wind most cranes never have to fight, which meant every lift near the top of its reach had to account for a boom tip that wasn't exactly where the operator's eye told him it was. At the top of the perimeter columns, crews welded together 48 massive box-shaped steel sections, each one 26 feet long and made from corrosion-resistant weathering steel, joining them into a single, unbroken ring strong enough to squeeze the entire roof structure inward under compression. From that ring, cables were stretched inward to a center tension ring, 100 tons of manganese vanadium steel, 41 feet across, welded together from 4 separate sections, and hung in the exact center of the arena, like the hub of a wheel, with no spokes touching the ground. Nobody sees this trick coming until it's explained. Nothing holds that roof up from underneath. No forest of interior columns, no load-bearing walls climbing through the seating bowl, just 48 cables, radiating out from that center ring like spokes on a wheel built for giants, pulling inward against the outer compression ring, hard enough to keep a 150-foot drum standing on tension alone. An architectural historian once said, "Walking into the old station made you feel like you were entering the city like a king." Whatever you feel walking under this roof, it isn't small. You're standing under thousands of tons of structure, held up by nothing but steel wire pulling against itself. 48 cables, each capable of holding 800 tons, in tension between that outer compression ring and the inner tension ring, let the entire roof hang in open air, with nothing underneath it. No interior columns, no obstructed sightlines. Just cold steel wire doing the work that thousands of tons of masonry used to do in the building, coming down 45 feet below it. Getting those cables from slack steel to a finished, load-bearing roof wasn't one lift. It was a sequence, run by hydraulic jacks, anchored to the compression ring, pulling each cable to tension a fraction at a time. Each cable was threaded from the outer ring to the center tension ring, connected at both ends through massive steel sockets. The ones anchoring the inner ring alone weighed well over 600 pounds apiece, and then tensioned gradually, cable by cable, in a carefully ordered pattern. Jack one cable too far ahead of its neighbors, and the entire ring could rack out of shape before the roof ever bore a pound of real load, with hundreds of tons of stored force sitting in a cable strung tight above a work crew. The crews weren't just hanging steel, they were coaxing an enormous circular structure into balance, one cable at a time, keeping forces distributed evenly across a ring 41 feet wide, suspended in open air above a moving railroad. Only once every cable sat at its final tension could the deck, the roofing material, and the 2 additional floors of mechanical equipment above the cables go on top, floors that, by design, also acted as a mass damper, adding enough weight up high to resist wind uplift and keep the whole suspended structure from swaying under a gust off the Hudson. The roof wasn't finished when the cables went taut. It was finished when the entire system had been loaded, checked, and proven to hold still. That steel didn't show up on site by accident either. Every plate girder, every box section of the compression ring, every length of high-strength cable had to be fabricated off-site, trucked or railed into the most congested few blocks in North America, and staged for a lift with almost no room for storage. A construction site with open space can afford to stack material and sort it out later. This one had none. Steel had to arrive close to the moment it was needed, in close to the sequence it would go up, because there was nowhere to park 14,000 tons of extra inventory in the middle of Midtown Manhattan. The schedule wasn't just a deadline. It was a logistics problem with almost no slack built into it anywhere. Underneath every one of those calculations sat the reason none of this was optional in the first place. This wasn't a green field where a delay just cost money. This was a working railroad that had to keep moving no matter what the steel crews needed. We still haven't answered how they threaded that steel over live track without losing a single train. That's not a small detail. That's the entire spine of this story. And it's about to get worse before it gets solved. The men who worked with the trains still running. That steel didn't lift itself, and it didn't go up in a controlled, empty lot the way a normal building gets built. Every crane operator, every iron worker, every laborer on this job spent 5 years working inside an active transportation hub, one that never stopped moving beneath their boots. Think about the daily reality of it from the other side, the side riding the train. A commuter walks down the same stairwell she's used for a decade, except now there's a plywood wall on one side where the wall used to be open, and beyond that plywood, 40 feet away, a crew is torch-cutting a steel beam that used to hold up marble. She doesn't stop. She doesn't even really look. She's catching a train. Multiply her by 600,000 riders a week for 5 straight years, and you start to understand the kind of discipline this job demanded from the men running the machines. One miscalculated swing of a crane boom, one piece of falling debris clearing the temporary decking at the wrong second, and this stops being a construction story. The summer of 1966 was, by multiple accounts from the period, close to unbearable. Demolition of the old head house was still grinding through its final stretch. Construction of the new steel frame was already climbing around it. Add July heat radiating off a site with almost no shade, plus a citywide airline strike dumping even more foot traffic into an already overloaded terminal, and you get a working environment described at the time as dust and turmoil, general confusion, layered 5 stories deep, with cranes swinging overhead through all of it. Timing became its own kind of skill. Heavy lifts, the ones most likely to cause a problem if something went wrong, had to be scheduled around the rhythms of a commuter railroad that didn't care what the construction crew needed. Rush hour was untouchable. Certain lifts almost certainly happened in the dead of night, when platform traffic thinned out and a crane could swing a load over track space with slightly more room for error, even if that error was still measured in feet, not yards. Every machine on this site carried its own particular version of the risk. The pneumatic riveting guns and torque wrenches driving friction bolts home, 45 feet up, threw enough noise and vibration to numb a man's hands by the end of a shift and swallow a shouted warning from 10 feet away. The cutting torches slicing through old steel beams, through sparks with nowhere safe to fall, in a space packed with dust, fuel drums, and wooden plywood partitions. The jackhammers, breaking up old foundation stone, shook loose material, with no clear path to the ground, except straight down through whatever decking happened to be underneath. And the diesel generators powering all of it ran inside what was, structurally, still an enclosed train shed, burning fuel in a space without anywhere close to the ventilation a job like that actually needed. None of these machines was the killer on its own. Stacked together, running at once, in a space this cramped, they turned an already dangerous job into one where a foreman had to track 5 different kinds of danger happening in the same 50 square feet at the same time. The architect on record for the project, Charles Luckman, had made his name designing office towers and corporate headquarters, buildings that got to sit on quiet, cleared lots. This job offered him nothing of the kind. Neither did the contracting firm actually running the field operation, a Texas-based construction company accustomed to big, open-country projects, suddenly responsible for coordinating hundreds of tradesmen inside the tightest, busiest few acres in the country. Every trade on this job had to unlearn its normal rhythm and relearn one dictated entirely by train schedules it didn't control. Coordinating that many trades on a site this cramped was its own kind of engineering. Iron workers needed clear air to swing steel. Demolition crews needed clear ground to drop debris. Electricians, riggers, surveyors, and concrete crews all needed access to the same few hundred square feet at different points in the same week, and almost none of them could work at full speed while another trade occupied the same footprint below or above them. On an open lot, you stagger those trades by simply giving each one more room. Here, there was no more room to give. The only lever available was time, split into shifts, sequenced with almost surgical precision. So the ironworker setting a beam at 2 in the afternoon and the demolition crew pulling stone at midnight never once occupied the same cubic foot of space at the same moment. That pressure was still building toward its worst stretch, the specific window where the gap between the demolition crew and the construction crew nearly closed to nothing, where old stone was still coming down in one section of the site while new steel was already crossing live track in another. That's next, and it's the closest this project came to the edge, the night the steel had to cross the tracks. By 1965 and into 1966, the job had entered its most dangerous phase. Not because anything had gone wrong, but because 2 crews with opposite missions were now working the same footprint at the same time. In one section of the site, wrecking crews were still peeling the last fragments of the old head house apart. Clamshell buckets and cutting torches working through the original steel-framed train shed. Jackhammers and pry bars finishing off the granite piers underneath it, including, for a stretch, the original 7th Avenue entrance. In another section, barely a few hundred feet away, iron workers were already setting the first structural steel of the new arena above operating tracks. That overlap was the most dangerous window of the entire 5-year job. Demolition dust and structural steel erection do not belong on the same site at the same time under normal circumstances. Here, there was no choice. The schedule that kept every train running on time also meant the wrecking crew and the raising crew were, for months, working close enough to see each other's dust. Think through what setting steel over a live track actually requires. A crane operator lifts a girder that can weigh several tons, swings it across open air, and lowers it into position within inches of where it needs to sit, while 45 feet below, on the original platform level, a train is either approaching, boarding, or pulling away on a schedule the crew has no control over. There's no pause button. There's no signal that halts a Long Island Railroad train because a beam is mid-swing overhead. The train comes when the train comes. The steel has to be ready and out of the way, or positioned with enough clearance that its presence changes nothing about what happens on the platform underneath it. Every column driven into that gap between the rails carried the same math. Miss the position by even a small margin. And that's not a delayed schedule. That's a structural conflict with a moving train, the kind of failure this industry does not get to have twice. So the columns were surveyed, checked, and set with a level of precision that had almost nothing in common with ordinary heavy construction, where a few inches rarely matters. Here, a few inches was the entire margin between routine and catastrophe. Money added its own pressure on top of the physical risk. A job this size, running on this kind of overlapping schedule, bled cash every day it fell behind. Cranes idle, crews standing around waiting on a train to clear before a lift could proceed. Steel sitting staged on trucks with nowhere to go. The eventual price tag on the whole project ran past $120 million, an enormous sum for the era, and every week of delay pushed that number higher. The crews were caught between two forces pulling in opposite directions at once. Move fast, because every idle hour cost real money. Move with total precision, because a mistake next to a live train wasn't the kind you could quietly fix and bill later. Both had to be true at once, for months, with no room to fail at either. Picture one lift, because it stands in for hundreds of them. The 70-ton derrick, guyed and anchored on a strip of decking barely wider than its own base, swings a perimeter column out over a gap in the temporary deck. 45 feet down, a headlight is approaching on schedule. The operator has one shot to set that column into a footprint surveyed down to the inch, because setting it wrong means either fouling the clearance envelope of a moving train or starting the lift over with even less room to work. He sets it. The train passes underneath a few minutes later, exactly on time, and nobody on board ever knows a 70-ton machine just finished threading a column past them with room to spare, measured in feet, not yards. Multiply that one lift by every column, every girder, every roof section, for the better part of 2 years, and you have the actual shape of this project's danger. Not one dramatic moment, but thousands of moments just like it, none of which were allowed to go wrong. And still, through every one of those lifts, across every foot of that overlap between the old station dying and the new one rising in the same footprint, the schedule held. No day of service was lost. No platform went dark. The busiest railroad terminal in the country ran on time, while a 14,000-ton steel skeleton climbed through the middle of it, close enough to the operating tracks that one miscalculated swing could have ended in something the record books would remember for the wrong reason. That's the real peak of this operation. Not a collapse, not a casualty, but the sheer, sustained nerve of running a functioning railroad and a rising steel skeleton through the same 600-volt airspace for months, lift after lift, and having it hold. The machines did their job. The men running them didn't blink. And when the last cable was finally spliced into that center tension ring, hanging 150 feet above tracks that had never once stopped moving beneath the entire operation, the arena that would swallow Pennsylvania Station whole was finally, physically, closed, where the old station still breathes. Madison Square Garden opened its doors on February 11, 1968, with a salute to servicemen, performances from Bob Hope and Bing Crosby, and 20,000 seats hung from a roof that had been threaded together, cable by cable, above a working railroad for the better part of 3 years. The total cost of the job ran somewhere north of $120 million, an enormous figure for the era, spent on a building that most of its ticket holders would walk into without ever once thinking about what was still running underneath their feet. What it replaced was gone in the way that mattered to the people who'd fought to save it. The granite came down. The glass ceiling that once flooded the concourse with daylight was gone. The columns modeled after ancient Roman baths were carted out through the same Hudson River tunnels that had once delivered them. Some of it dumped in the New Jersey marshland, the trains still pass on their way into the city today. An entire architectural era, the idea that a train station could be a temple instead of a basement, ended here, and it ended fast enough that the loss helped spark a new law in New York, protecting landmarks from ever being erased quite this completely again. Now go back to the fact this whole hook opened with the one left hanging on purpose. The old Pennsylvania station wasn't actually hauled away into memory the way most people assume when they hear the word demolished. Down at platform level, nothing moved. Not one track, not one platform. The same 21 tracks and 11 platforms that opened in 1910 are the exact same 21 tracks and 11 platforms running trains right now, tonight, underneath the arena floor. The old station's bones, its stairwells, its tunnels, The very geometry of how you get from the street to a train survived the entire 5-year war intact, buried under 150 feet of concrete and cable instead of erased by it. That's what the title of this story actually means. This building didn't just get built above live trains. It got built on top of a station that never stopped existing. A ghost floor plan still running full operations beneath 20,000 fans who have no idea, on any given night, that the platform their train pulled into is standing in almost the exact spot it stood in when President Taft's administration was still in office. The arrangement never really settled either. The station underneath has been called cramped, dim, and low-ceilinged by generations of commuters who never got to see what stood there before 1963. For decades, officials and planners have floated proposals to fix it, some of them requiring the arena itself to move, something the Garden's owners have consistently refused to consider, since the site, sitting above the busiest transit hub in the country, is, by any commercial measure, close to unbeatable. Every few years, the argument resurfaces in some new form, with new renderings, new committees, new promises, that this time the tangle finally gets sorted out. It never quite does, because moving a building that size off the busiest transit hub on the continent turns out to be almost as hard as building it there in the first place. A partial fix finally opened across the street in the old James Farley Post Office building in the early 2020s, adding a daylit concourse the original replacement station never had. But the core of it, the 21 tracks, the 11 platforms, the exact footprint the ironworkers built around, inch by inch, while trains kept running beneath them, is still down there today, still buried under the arena floor, still standing in the same spot it's occupied for well over a century. The old Garden that felt owned before this one, the third one, sitting a few blocks north on 8th Avenue, came down for good the year this one opened, one arena replacing another, almost like the city needed exactly one Madison Square Garden standing at all times, and refused to allow a gap. The men who ran those cranes and derricks, who drove 500 columns down through a live railroad without losing a single scheduled train, did something that had never been attempted at this scale before. They didn't get to shut the job site down and start clean. They got a live wire, a working commuter railroad, and a 5-year deadline, and they built one of the most recognizable arenas on the planet through the middle of it, without stopping the trains for one day. They don't build them like that anymore. Not because nobody could, because nobody would agree to try it. Not with 600,000 people a week walking through the job site. Not with a schedule that couldn't move an inch. Not with a live third rail running under every column they sank. They did it anyway, and somewhere below the ice, below the seats, below every game and concert this building has ever hosted, an entire train station nobody ever really tore down is still quietly running exactly where they left it.